Hi guys, these are our last set of notes for physical science. Very hard to believe, but we are here. So we just covered electricity. The last topic we have to talk about is the universe. Astronomy is a specific branch of science that deals with space and the universe as a whole. People get this mixed up with astrology. Notice how those two words are different. Astronomy is a study that deals with space. Astrology is a method that attempts to study how things in space affect people and events on Earth. This is a belief, it's not a true science. These are things like horoscopes and signs, stuff like that. Okay, so those are different, but this we're going to be focusing on astronomy. Beginning of the universe. Scientists believe that the universe was created 4.6 billion years ago. Lots of people, they don't really comprehend how big a billion really is. So just to put this into perspective, if I gave you $1,000 a day, 7 days a week, how long would it take you to get to $1 billion? Okay, $1,000 a day to get to $1 billion. It actually would be longer than your lifetime. It would take over 2,000, almost 3,000 years, where if I was to ask you how much it would take to get to $1 million, that would just be a few years. But $1 billion, that would be 2,700 years. It's a big difference. So, 14 billion years ago, all of the matter and energy were in one dense, tiny, very, 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 very small space. Okay? Then that matter exploded, and it's been expanding ever since. This statement that I just said is representing the Big Bang theory. It's a true theory that exists. Now notice we don't have somebody that was there billions of years ago to vouch for this, right? But we do have some scientific research and studies that support this theory. Edwin Hubble, he was the first to conclude that the universe was expanding. So he observed spectral lines, which we'll talk about shortly, from other galaxies. He found out that everything that he was looking at in space shifted towards the red end of the spectrum. Remember that spectrum of lines when we talked about waves, Roy G. Biv? He was realizing that all of these things were giving off a red color. He explained this by the Doppler effect. When objects are moving away, the wave gets lower and the lower frequency. So remember, red light has a lower frequency than the opposite, which is violet. So I have some pictures on the next slide to show you. But the opposite of this, when objects were moving closer to Earth, he noticed them emitting a blue light or a blue shift. This meant that the frequency was getting higher. It was moving closer to Earth. Therefore, the frequency was high. Therefore, it produced the higher frequency of the blue light. Okay. So on this picture, remember my electromagnetic spectrum. Red light has a lower frequency than blue light. Okay. And remember this, my Doppler effect. Again, when we're talking about waves. If something is moving closer to you, the frequency is going to be higher. Just like when the car is moving towards you, you hear it as it is louder because the sound waves are at a higher frequency. But if something is moving away from you, that wave is getting more spread out, causing the frequency to be lower. And what's the lower frequency color? Red. Okay, so again, to summarize this, Edwin Hubble observed that when things are moving away, it's going to give off this red spectral lines. And if things are moving closer to the Earth, it's going to give off the blue. So that's redshift and blue shift. Before I go into galaxies, just want to talk about the Big Bang a little bit more. So he realized that things were moving away from the Earth, right? So if things were moving away, they were constantly moving away, that meant that at some point they had to have been closer together, right? So if things are constantly moving away, back in time, they were at a closer proximity to each other. So they were closer, and that's where they got the idea that they once were at this one tiny, tiny, dense spot. And ever since that explosion, it's been expanding ever since. All right, galaxies. Galaxy is a collection of millions to billions of stars. Gravity is our friend that holds everything together. There's three types of galaxies out there that we're aware of. One is a spiral galaxy. This is in the shape of a spiral. It includes the Milky Way, which is the galaxy we live in. There's elliptical galaxies and irregular galaxies. So this is a picture of a spiral galaxy right here. We can see how it starts in the center and it is spiraling out. I have elliptical, which are really just circular, and irregular, which don't have a defined shape. So these are my main types of galaxies in space that we are aware of. Just for a little perspective, this whole image right here is our Milky Way. This is our galaxy. And just this little part right here, that one star in this galaxy, remember there's millions of billions of stars in one galaxy, right? This one star is the sun, which if I blow that up, our solar system is surrounding that one star. So it's kind of weird to think about that. We think of our solar system as pretty much all that's out there, right? But that's just one star out of the billions and trillions of stars out there. So it's kind of funny to think about it that way. So let's talk about stars for a sec. Stars are made up by dust and hot gas. Just like plants and animals, they go through different stages of their life. Stars, they're not alive, but they do go through different stages as they are older compared to when they're younger. We're going to be using the term light years to measure the distance in space. So a light year is a distance. It's not an amount of time, it's a distance. And one light year is 9.5 trillion kilometers long. That's pretty big. How do stars get their energy? They get their energy through nuclear fusion. So I don't know if you remember from nuclear chemistry back in December, but when two atoms combine, that's called fusion, and that creates a lot of energy. And that's the type of energy we see or is found in our stars. The brightness of a star depends on the temperature of a star, the size, and the distance from Earth. A star's color is related to the temperature. Definitely be asking you questions about that statement right there. A blue star are the hottest, while red stars are the coolest. Now, granted, a red star is pretty hot still, but it is significantly cooler than a star that appears blue. And think about it in terms of my colors, right? Blue light has more energy, so it makes sense that the blue stars are the hottest, while red light has less energy, therefore red stars are the coolest. So our sun. The sun is the closest star to us, and that's only about 93 million miles away. So I can't even use a light year away. Remember, that's 9.3 trillion miles away is one light year. The sun is a lot closer than that, 93 million miles. Our sun appears yellow, so it's in the middle of that spectrum. So it's at a medium level of temperature. It's not insanely hot. It's not the coldest star out there. It's in the middle, giving us a yellow appearance. The brightest star we see is about 8.7 light years away, and this is named Sirius. That's a picture of it too. We see Sirius as more of a blue color, so it's a lot hotter. giving us off a lot more energy. So back to those spectral lines. Edwin Hubble was observing those red and blue spectral lines, right? Going back to our atoms for a bit, every different element has a different amount of energy, right? Because we know that every element has a different number of electrons. And the more electrons an atom has, potentially more energy it has. We also know that the different colored light have different amounts of energy, right? Blue light has more energy than red light. So astronomers are able to look at a star's spectrum lines and match the color they see to specific elements. So remember, these elements, they have different amounts of energy. Therefore, they're going to give off different colors of light. So these astronomers, they're able to figure out what elements are made in these stars. So for example, this is a picture showing us some different elements in the spectral lines that they might see. So an element like neon would, if you looked at a sample of neon, you would be able to see these spectral lines in this color range. And if you were to see those spectral lines, you can gather, oh, they must have neon there. Or if I was to see a pattern like this, a single red, some green, and some violet over here, I could, oh, that star must have some hydrogen. Okay? And our life cycle of stars. So a star is not alive, it's just hot gas and dust, right? But it does change over time. The first stage of a star is called a nebula. Then we go to a protostar, and then it's the actual star. It turns into a red giant, and then to a white dwarf. Sometimes after the white dwarf, it explodes, forming a supernova, then a black hole. So a nebula is just a cloud of gas and dust, right? It hasn't formed anything yet. Then it's going to start to condense and to collapse and start to spin, forming the protostar. Pressure is going to build up and it's going to create all that energy from fusion and fission, and that's when the real star happens. As fusion reactions decrease, it starts to die and become a red giant. So those hydrogen atoms, they're not going to be able to fuse together forever, right? But eventually that will slow down and it'll start to die, the star. Once the red giant gets smaller, it cools off and becomes a white dwarf. So, to answer the question, will our sun live forever? No, it will not. It's just in the middle of its life here. It still has plenty of time. It won't die in our lifetime or our great-grandchildren's lifetime. It still has a long way to go, but it will eventually die at some point in the future. And if we don't have our sun, we don't have any of the planets in our solar system. So let's talk about planets really quickly. Planets form by small particles colliding and sticking together. So I have rocks in space, and if they collide enough, they're going to stick together and gravity is going to keep them in that shape. So the moon. The theory about the moon is as the Earth was still forming, okay, so our planet Earth was forming, a Mars-sized body struck the Earth. So a piece of rock struck this forming piece of Earth, and at the impact, a large piece of our planet was blasted off into space. That piece of Earth started to orbit due to gravitational pull. So the moon is essentially just a broken off piece of our planet. And that's it. We'll spend a couple of days on focusing on these notes of the universe. We'll take a quiz over it, and that will be our year. Email me with any questions you have over grades or this material.